Hello everyone. Today I am going to show you how to conduct the McNemar test in R. The McNemar test is applied to a variety of datasets. One typical example is to analyze the proportion of a binary variable, let's say absence and presence, in two successive surveys. Let's say we have a group of animals and a proportion of those animals are infected with a pathogenic bacteria. And then we apply an antibiotic and we want to see how the antibiotic change the proportion of infected animals after time. So we will illustrate that here in R with simulated data. If you want your simulated data to behave consistently when running multiple times the same code, you set a seed for the random number generator, and then we will first generate a data frame that contains data that is supposed to produce non-significant results after the McNemar test. It means that the proportion in one point in time are non-statistically different from the proportions in the second time point, right? And then we will call this data frame non-significant, and that will be a data frame, and it will have only two columns. We will call the first column time point 1, and this will be equal to a random sample that contains let's say, because we are talking here about pathogenic bacteria, let's say that the majority of animal has the bacteria, so they are yes at the beginning. 80% of animals are yes, and only 20% of the animals are no. So let's now generate another column in the same data frame for the next timing point. And we will generate it with exactly the same formula. So the proportions will be very similar. Not identical because this is randomly simulated. And here we will say we want to have, let's say, 200 animals, and we want to conduct this sampling with replacement. Those are just statistical tidbits, right? Not too important because this is just to simulate the data. Okay, now we wrote that. The first step to conduct the McNemar test is to generate a contingency table for non-significant data in this case, and that's done simply with the function table in R. And then we will calculate the contingency table between the two columns of the data frame we just generated. Oops, sorry, there is a mistake here. This time point should be called time point 2, not the same, right? And otherwise we will confuse here the table function. And now correctly, time point 2. So what do we have in this contingency table is just a cross tabulation of instances or animals that did not contain the bacteria at the beginning and did not contain the bacteria at the end, did not contain the bacteria at the beginning, but yes, contain the bacteria at the end, and contain the bacteria at the beginning but not at the end, and contain the bacteria at the beginning and at the end. So by visual inspection of this contingency table, we see that the antibiotic was not effective because most of animal contained the bacteria at the beginning but still contain the bacteria at the end. But let's test that more formally with the McNemar test and of the contingency table of NS. And then if we run that, and then we see that indeed the p-value for the McNemar test is non-significant here. So very quickly now, because you already know the process, let me copy this data frame and generate now another data frame that we will call significant, and will contain data that is significantly different. So let's say that here the antibiotic cure the majority of animals from the bacterial infection, and we generate the same thing. And so, sorry that I am not very used to the Mac keyboard yet. And now we will generate a contingency table, but for significant data that will be the data frame significant in this case, right? And the same columns, because we just call the columns the same thing here. We generate this contingency table now, and from here CT significant, and from here we can see that the majority of animals that had the bacteria at the beginning did not have it at the end. So this should produce significant results, right, for the McNemar test of the contingency table of significant. We'll run that, and we see that indeed the p-value is very, very small, right? It's 2.2 to the 10 to the minus 16, and that's how the McNemar test works. I hope you enjoyed the video. I will see you soon.